Hello viewers, welcome back to my channel, and today we are going to discuss another interesting question on conflict serializability and view serializability. So this is a viewer question, video on demand, so let's dive into it. So as you can see in this question, we've been given with two schedules, right? We have some transactions performing some operations. So R here implies a read operation. So for example, R1X here means that transaction T1 performed R or read operation on item X. Similarly, R2X means T2 performed a read operation on alphabet X or item X. Similarly, W1Y means T1 transaction performed a write operation on item Y. Okay, so that was about the notation. Now let's see what are the things that are asked in the question. So in the question, the viewer asked me that we need to form the precedence graph. We need to look if these two schedules are conflict serializable or they are conflict equivalent. That means uh, can we find out a conflict equivalent schedule, okay, for these two schedules individually. Remember, we are not finding out if they both are conflict equivalent to each other or not. First of all, we'll check if they are conflict serializable one by one, and then if it is conflict serializable, then we'll also find out the possible conflict equivalent schedules. Okay, then view serializable. So if the schedules are view serializable or not, and if we can find some view equivalent serial schedules. Now, if you think about the connection between conflict and view serializability, so you should recall we have seen I've made lots of videos on this. You can look a past video, but a quick recap is that first of all, we draw the precedence graph in which we plot the conflict pairs. Okay, so what are the conflict pairs? We'll talk about it quickly. So first of all, we draw the precedence graph in which we plot the conflict pairs. Okay, and if the precedence graph has a cycle in it, that means it is non-conflict serializable. So we get to know if the schedule is conflict serializable or not. If it does not contain any cycle, so if the precedence graph is acyclic, then it is conflict serializable, and any schedule which is conflict serializable is also view serializable or is also serializable. That we've already discussed in a in a basic video where I've drawn the entire flow chart, that if a particular schedule is conflict serializable, so if it is a yes, then it is serializable. You don't need to check anything else, okay? But if it is a no, so if it is a no, then you check for view serializability. So if you check if it is view serializable or not, and if it is a yes here, okay, so rather I should draw it in this direction. If it is a yes, then also it is serializable, and if it is a no, okay, so if it is a no, then it is for sure it is non-serializable. So an important point to note over here is that let's say if a schedule is if while checking conflict serializability, we get to know that it is non-conflict serializable, that there is a cycle in it. So we get to know it is non-conflict serializable, but we cannot directly say that it is non-serializable. So non-serializability only you can say after you have checked for view serializability. Okay. So step one is that you check conflict serializability. Okay, one of the methods is to draw the precedence graph for it, and step two is that if you get to know that okay, this is non-conflict serializable, then you go for view serializability check, and after that you get a confirmation that whether the schedule is serializable or not serializable. Generally in GATE they ask the question if the schedule is serializable or not, but there can be multiple part questions, right? So as the question that this viewer posted, it is a very interesting question. So let's dive into it and let's look how we can solve this. So as I said, first step should always be to draw the precedence graph. Okay, now to draw the precedence graph you need to know about conflict pairs, non-conflict pairs. Again, there is a detailed video on that, so I'll put the link in the description. You can go back and look into it, but a quick recap, because I want you to solve the question in one go in this video. So conflict pairs are which pairs? Conflict pairs are of this form, where if you can see there is a read performed on an item A by, let's say, T1, and another transaction T2 is performing a write on the same item. Okay, similarly, the order of the transactions can be reversible. That is, let's say T2 was performing read on A, and then T1 was performing write on A. Okay, so read, write pairs are all conflict pairs. But an interesting and important thing to note over here is that both the transactions should differ, and both the items in the operations being performed should be same. Okay, so basically two different transactions are performing two different kinds of operations or same kind of operation when it is right. Okay, so two different transactions are performing operations on the same item, then only there is a problem. Let's say if the same transaction is performing a read write operation, for example, if it would have been R1A W1A, then this would have not been any problem. Okay, this is not a conflict pair. There is no problem. The entire thing is being done in a single schedule, in a single transaction, right? So there is not, this is not a conflict pair. So conflict occurs only when there is this two different transactions are performing operation on the same item. Why we call it a conflict? Because we need to take a note of it that okay, so we need to take a note of it that okay, let's say if R1 read an old value and W2, basically T2 has updated the value of A, then R1 should not perform any additional operations without reading the correct value of A or the updated value of A now. Okay, so either we can undo or roll back the W2A operation, or we should perform the R1A again so that all the further operations of T1 are performed on the correct value. So that is a bit of basic on why it is a conflict. What do we need to do in order to make sure that every operation is happening on the correct value. Of course, we've discussed that in detail in other videos, which I'll paste the link in the description box below. You can go there and get the details. But coming back to this problem, okay, another example of non-conflict pairs are when we are performing operations on two different items. So for example, R1A and W2B. Now R1A means transaction 1 is performing read operation on item A, whereas W2B means transaction 2 is performing the write operation on item B. Now since both the operations are being done on two different items, so it does not matter in which order they happen, right? Because they are not interrelated, they are independent of each other. So therefore these are non-conflict pairs. There is no problem in these pairs. They can happen in any order. We do not need to take care of that okay, this should happen in this particular order only. Even if we change the orders of any other pairs, we should not change the order of these pairs. This constraint is not valid here, whereas for conflict pairs, we need to make sure that the order of conflict pairs is never changed. Okay, so the trick to identify the conflict pairs is that look for operations on the same item, look for operations on the same item but with different transactions. Okay, so for example, this is a schedule. When we have to identify the conflict pairs, the easiest thing is just start with a single item, go item by item. For example, start with X, then go to Y, then go to Z, and try to check that, okay, two different transactions, where is the thing where two different transactions are performing these read write write read or write write operations, but they are performing it again on the same item, right? So since you are going item by item, you'll always look for the same item but two different transactions performing different kind of operations. So let's implement it now. So we have schedule S1. Okay, so let's start with X. Now for X, if you can see, there are only two operations, R1X, R2X, and they are not conflict pairs, right? Read is not a problem until and unless you have a write operations. Both are performing initial read. It is not being updated by any of the transactions, right? X is not being updated by any of the transactions. So this is not a conflict pair. Okay, let's move on to Y then. So for Y, we see that, okay, first of all, we have a write operation here, W1Y. Okay, then we have W2Y. So a classic case of WW with the same item, different transactions. So it is a conflict pair. Okay, so I have labeled it as 1. Okay, so this is number 1. Okay, now similarly, let's move on. So W1Y and then R1Y. No. Why? It is not a conflict pair. Why? Because the transaction number is same. In the same transaction, there are no conflict pairs. Okay, let's move on. W1Y and R2Y. So if you notice, what am I doing? I am sticking one end over here and then I am comparing it with the other operations in the segment, right? I am comparing this operation with the following operations for the same data item. You can also do it in the same manner. So of course there can be many other methods. I'm just sharing one method which I follow. Okay, so W1Y, R1Y we've already checked, no problem. W1Y, R2Y. So classic case of WR performed on by two different transactions, T1, T2 on the same item. So yes, this is a conflict pair. So you can label it as W1Y, R2Y. So we can also write it down over here. So first of all, we identify W1Y, W2Y. Then there is W1Y, R2Y. Okay, so we have two conflict pairs now. Let's see if we can find more. So now we are done with this particular operation. Let's start again comparison with this one. Okay, so W2Y and then we'll compare the next operations with this. So W2Y, R2Y, sorry, W2Y, R1Y, yes. Both the transaction numbers are different, item is same. So this is another conflict pair. W2Y, R1Y. Okay. Let's compare this with this one. So W2Y, R2Y, again same transaction, it cannot be a conflict pair. So we've identified we have three conflict pairs. This can be another gate question. How many conflict pairs are there in your schedule, right? So you have three conflict pairs. Okay. Now the easiest part remaining is we need to plot it in the form of a precedence graph. So how do you draw the precedence graph? Again, there is a basic video on this, but let's start. So we'll first of all look for how many transactions we have. We have two transactions. So we'll draw the two transactions. We have two transactions as nodes of the graph, and then we have edges as the conflict pairs, right? So let's plot W1, W2, Y. So from 1 to 2, right? What is the order? From the first transaction to the second transaction. So that's how we'll draw the edge from 1 to 2 and we label it as W1Y, W2Y. Now, similarly, there is another edge from 1 to 2. If you can see this one also, W1Y, R2Y is also an edge from 1 to 2. So we label it here only, okay? Comma W1Y, R2Y. And then we have another edge W2, R1, right? W2Y, R1Y. So this is from 2 to 1. If you see, it goes from 2 to 1. So therefore the direction is from 2 to 1 we have drawn, and the labeling is W2Y, R1Y. Okay, so as you can see, there is a cycle here, right? There is a cycle. You go from T1 to T2, and then from T2 to T1. You can again go from T1 to T2. So there are edges existing in the graph such that it is a cycle. So if it is cyclic, it is non-conflict serializable. So we have that this schedule is non-conflict serializable. What do we do if it is non-conflict serializable? See, if it is non-conflict serializable, you have to check for view serializability, which is the third part. Okay, but we have the answer for conflict serializable. We have precedence graph. Can we find out conflict equivalent schedules for this? No. Why? Why you cannot find conflict equivalent serial schedules? Because it is non-conflict serializable. If it was conflict serializable, then we would have found different possible serial schedules, which we call conflict equivalent serial schedules. Okay. So coming to S2 schedule, in the same manner, now we'll look for conflict pairs in this schedule and we'll plot the precedence graph. Okay. So pay attention. Again, we'll start with item X. Let's start with item X. So in item X, we have what operations? If you see, we have R3X, R1X. Any further operations? No. So we have only two operations, R3X and R1X. Okay. So clearly there is no conflict pair. Why it is not a conflict pair? Because read is not a conflict pair. Although the read operation is being performed by different transactions, it is not a conflict pair. Conflict pair occurs only when there is read write read, or write write. Okay, so there is no conflict pair because of X item. Let's move to Y. So let's move to Y. So when talking about Y, now the item has to remain the same, right? So let's see how many operations we have for Y. So for Y, we have only one operation. If you can see, no operation here, no operation here. So single operation cannot create any conflict pair, right? So let's move to Z. Now moving to Z, we have three operations over here. If you see, so this is read. Let's start with this one, read, and then compare with this one, which is write. Okay, but the transaction numbers are same, so no conflict pair occurs in the same transaction. We need to have a different transaction, so it is not a conflict pair. Let's check with the next one. So this is read. Now read cannot be a conflict pair again. Okay, because the examples of conflict pairs are all listed here. So no conflict pair because of this. Let's move to the next item and compare this with the next one. So if you see, write Z and then read Z. So write, read, yes, it is a conflict pair. Let's check the transaction numbers. Yes, transaction numbers are also different. T2, T3, item is same. So yes, this is a conflict pair. Okay, so we have a conflict pair, but only one conflict pair over here. We can write it down, W2Z going to R3Z. Okay, so the order in which they are occurring, that shows the direction of the edge. Okay, so how do we draw the precedence graph? Again, we have three nodes, T1, T2, T3. Why? Because we have three transactions in the schedule instead of two as we had in S1. So we have three nodes, T1, T2, T3. Okay, but where is the conflict pair? It's only between T2 to T3. So we draw it in this manner, T2 to T3. There is a single edge which is labeled as W2Z, R3Z. Now since there is no cycle in this graph, it is acyclic, therefore it is conflict serializable. So yes, S2 is conflict serializable. Okay, S2 is conflict serializable. S1 was not conflict serializable. So now for this particular graph, we can find out its conflict equivalent schedules. Okay, why? Because it is conflict serializable. Okay, so we can find out conflict equivalent schedules. Sorry about this, just a second. Yeah, let's move it here. Yeah, okay. So Focusing on S2 now. Yeah, so this is conflict serializable. Okay, now let's find out a particular order, right? In which order can we put it? So, the order is defined by the conflict pair. Okay, so the conflict pair says that T2 should always come before T3. So the only constraint is T2 should always come before T3. There is no constraint on T1. So I can form various combinations over here. I can either say, okay, T1 will occur first and then T2, T3. Then I can say T2 will occur first, then T3 and then T1. Or I can say T2 will occur first and then T1 and then T3. Okay, so three combinations because there was no restriction on this. Okay, so I can form three combinations. So there are three conflict equivalent serial schedules. Let's also verify by actually adjusting the um, operations we had, because the important condition to form a conflict equivalent serial schedule is what? Do not change the order of conflict pairs. The only important necessary condition to form conflict equivalent serial schedules is that we cannot change the order of conflict pairs. How many conflict pairs we have? We have only one. So we just need to make sure that W2Z always occurs before R3Z. Now, it's not necessary that R3Z should occur immediately after W2Z. No, there can be many operations within these two operations, but the order should be maintained. Okay, I hope you got the point. Okay, so let's try to form the different orders uh, 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 we just jotted down here. So I've written all these three orders over here. Okay, so T1, T2, T3. So how do we form this? First of all, we try to shift all the operations. So first of all, we try to shift all the operations of T1 to the front, then all the T2 operations should come, and then T3 operations should come, and we should be able to do this without disobeying this rule, okay, without changing the order of this conflict pair. Okay, so if we compare what was this S2 schedule, we have it over here. I'll write it here again, just to, because I'll have to move it down, I think, or no, it can be done easily. Okay, fine. So we have S2 schedule. Okay, anyhow, R3X, R1X, W1Y, R2Z, W2Z, R3Z. Okay, it's easy to compare from here. Now we need to make all the operations of T1 to front. Okay, we need to move them forward. Okay, so no problem. There is only single operation here, W1Y. I can easily move it. And there is read X also, sorry. So there are two operations. I can move them on in front. Why? Because there is no conflict. There is no write read order that I'm disobeying, right? I see, once you've identified the conflict pairs, you don't have to check it again and again that whether I am disobeying the read write order, because there is only one conflict pair. Only for this you have to look. Okay, so when you have to identify, when you are working with T2 and T3, T1 does not cause any problem. So simply you can move all the operations of T1 in front. Okay, so I've moved all the operations of T1 in front. Just for the sake of explanation, I was explaining that, okay, it's not causing any problem with R3X. It's not a conflict pair because both the operations are on different items. R1X and W1X, W1Y again being performed on the same transaction. So you can easily move this over here. Okay, the only change we have done so far is we moved it over here and we moved these to the front. Okay, next is we need to move T2 operations to the front. Okay, now an interesting thing over here is that one may think that, okay, read and write may cause a problem, right? Read, this is R3, okay, different transactions, and this is write. How can I move T3, which is a read operation, to the end and T2 before it? This is a read write conflict, but no, it is not a conflict. Why? Because both the things are happening on different items. Okay, R3X W2Z. Okay, when the items are different, it is not a conflict pair. Okay, then the read write order does not matter. You have to obey, you have to see the read write order with respect to the items you are considering, which is a very important point. Okay, so coming back to the problem, so can we move T2 to the front, to the second position? So let's see which are the T2 operations, this and this two operations, R2Z, W2Z. Yes, we can move it over here. We moved R2Z, W2Z here. So all the operations of T1 are here, R2Z, WZ, and then basically I'm just moving R3 behind this at this position. Okay. So I moved R3x over here. So again, just now I explained it is not a conflict with these items. So no problem. We can move it here. So clearly we can form it in this order T1, T2, T3. This is a possible conflict equivalent serial schedule. Similarly, can we rearrange the items in this manner T2, T3, T1? So as you can see, I've rearranged it again. T1 is working with X and Y, whereas T2 is not working with X or Y. Okay, so there is no conflict here. I can easily move T2 to front. Okay, and then after T2 I have kept T3, which is this order only. I am obeying this order, so there should be no problem. And again I have explained that the only possibility of conflict which would have occurred between R1 and R3 would have been this W and R, right? But both of them are on different items. So again, they also don't have any conflict. So I can easily move T1 operations towards the end. So this is how you can arrange it. Okay. Now the last possibility T2, T1, T3, T2, T1, T3. So T2 operations will come as is. Then T1 operations I've moved over here, and then the T3 operations. Okay. So the three possible conflict equivalent serial schedules also we have given. So our second part also gets done. Now we need to solve the third part, which is view serializable. We need to check if the schedule is view serializable or not. So the notation or the book says that if a schedule is conflict serializable, by default it is also view serializable because it is serializable. So although you don't need to check for view serializability, you can simply write that since it is conflict serializable, so it is also view serializable. But if there are marks for step marking and everything, it's safe to explain the view serializability part also, so that there are no marks cut for say you've not done all the steps, you've not explained view serializability. So it's safe to solve this as well. So that is why I also solved view serializability. So for view serializability, again there are lots of solved examples and the basic video which explains all the things. You can go back and view that. But in order to solve this question, I have answered all the parts. I'll explain you. So let's move it little bit here. Yeah, I think that is fine, but I need the schedule, so I'll keep it here. Okay. Yeah, so for view serializability, we check three basic things. First of all, we form a table in this manner, and for each item we check initial read, update and final update. And also important thing is, whatever order you form, you have to obey the order of read write sequence where the conflicts are occurring. Okay, important thing, read write sequence where the conflicts are occurring, or read write sequence of same items being performed by two different transactions, which is the definition of a conflict pair. Okay, so let's start with this. We have the schedule over here. Okay, so we'll look for initial read. Now what is an initial read? Quick update. Initial read is what? That when a transaction is performing a read operation before the item has been updated by any other transaction. Okay, so in simple language, any read operation before a write operation on the same item. Okay, any read operation, I'll write that down for you. Any read operation before a write operation on that item. is an initial read. Okay, now this write operation can be performed by the same transaction or some other transaction. It does not matter. This is very important definition. Many people are confused about initial read, so please make sure you have the clear understanding of what is an initial read. Okay, so yeah, so let's now try to identify the initial reads for this schedule. So talking about X, again we'll go item by item. We have all three items listed over here. We have three columns. So we'll fill this up. So for X, so is any transaction updating it? No, there is no update operation, right? There is no write operation. We call the update operation as the write operation, right? So no transaction updating it. That means both the transactions are performing initial read. Okay, so you can write it in any order, T1, T3, T3, T1, no problem. Both the transactions are performing initial read. As there is no transaction performing the update operation or the write operation, I've left it blank, written it like this dash, and final update, which transaction is finally updating it? No one is updating it, so how will anyone finally update it, right? So this is also kept blank. So that means there is no constraint that we'll get from item X. Okay, so this is of not our concern now. We don't need to look on in X. Okay, nothing important has been found over here. Okay, coming to Y now. Y also, there is a single operation. As you see, there is only one update operation which is being performed by Y. So which is being performed by T1. So is any transaction reading Y? No, no transaction is reading it. So there will be no initial read. So therefore I kept it blank. Okay. Coming to update, there is a single update operation. So T1, and if there is no other transaction updating it, so this is also the final update. Okay. So T1 here. Okay. Coming to T3 now. Now T3, is any transaction reading, sorry, coming to Z. Coming to Z. Coming to Z, is any transaction reading Z? Yes. We have T3 reading Z, we have T2 reading Z. Let's check about initial read. Initial read, what does the definition say? Any read operation performed before a write operation on that item. So we see a write operation here, right? This is a write operation. So any read operations or all the read operations on Z before this. So there is a single read operation on Z before this, which is R2Z. So only T2 performs an initial read. Okay, T2 performs an initial read. Remember, initial read and read are two different concepts. Don't make a mistake. Don't write T2 and T3 over here. No, only T2 is performing initial read, because after this T2 updates the value of Z. So this read is not an initial read. Okay. Okay, coming back to the problem, we have identified initial read. Let's move to update. Update means which transactions are updating the value of Z, which transactions are performing the write operation on Z. So let's see for write operation on Z. So as I can identify, there is this write operation being performed on Z by T2, and there is no other write operation on Z, right? There is no other write operation on Z. So only T2 is performing the write operation, okay? And since there is no other transaction updating it, so T2 only performs the final update, right? T2 only performs the final update. So generally, why we form this table? Because generally what happens is we get multiple transactions which are updating the value of an item, and then there is a single transaction which is finally updating it. So the order comes that, okay, whatever transaction is updating this item will go the last. Okay, but there is no such thing over here. So again, we cannot draw any interesting trends from here. We'll see such trends maybe in the other schedules, S1, for which we'll solve it. But from this table, we cannot draw any trends. We cannot come up with an order. Similarly, we cannot come up with an order over here. So let's move to our fourth check, which is order of read-write sequence of conflict pairs. So which was the conflict pair? You had only one conflict pair, W2Z and R3Z. So according to this, you need to obey the order that, okay, W2Z, that means T2 will always come before T3. So based on this, we have already formed the schedules. So the same would be the answer. So these are the other possibilities I've drawn over here. Possibilities. Okay, but the strict constraint is T2 will come first and then T3 will come. Any number of transactions can come within. So the possible schedules are T1, T2, T3, T2, T3, T1, T2, T1, T3, which we have written over here also, and we've also checked that it's possible to form them. So our view serializable equivalent schedules or view equivalent serial schedules are same as conflict equivalent serial schedules, which we have verified. Now you could have straight away skipped this step and written that okay, conflict equivalent serial schedules are equal to view equivalent serial schedules, because generally when you get a conflict equivalent serial schedule or when you get a yes that okay, this schedule is conflict serializable, you do not check for view serializability. Okay, so whatever schedules you identified at the conflict serializable part are the exact answer, and that's what we have identified. Okay, that's what we have verified. Okay, now let's come to the schedule number 1, which was non-conflict serializable, and for which we have to identify that if it is view serializable or not. Okay, so view serializability check for S1. I've written S1 again over here because we need to work with it, and again we'll work with it, but first we have to write down what? We have to write down the conflict pairs, because when we'll check for read write sequence, then we have to check these, right? So I've written the conflict pairs. Okay, so the conflict pairs here are what? If you check over here, so a cycle was being formed, right? There were 3 conflict pairs. We can write all the 3 or we can write 2. So I'll write all the 3. I'll check which one I have not written over here. Yeah, so it was W1, W2. Okay, so W1, W2, why I'm not written? Because it is not a read write sequence, it is write write. So we don't need to take care of write write. So therefore we have only 2 read write conflict pairs, which we have written over here. Okay, so everything is fine. Let's come back here. Yeah, so these are the read write sequences we need to take care of. I've also marked them over here. So as you can see, this write, read, write, read. Okay, now let's form this table: initial read, update, final update. Okay, so initial read, so condition or the definition was any read being performed before a write operation. Let's move item by item. We have only 2 items over here and 2 transactions, T1, T2 and X and Y. So let's start with X. If we see X, these are 2 read operations happening and there is no write operation happening on X, right? So both the reads are initial reads. So therefore T1, T2. Okay, coming to Y, there is a read operation happening on Y, but before that there have been 2 write operations, right? So this is not an initial read, right? There is another read operation happening on Y over here, but again 2 write operations have happened already. So no initial read for Y. So we've kept it blank. Okay, now update. 2 write operations happening on Y, no write operation happening on X. We've already discussed that. So blank here and blank here. Coming back to Y, 2 write operations happening on Y, T1, T2. So we write both T1, T2. Now which one is updating it at the end? T2 is updating it at the end. So final update goes to T2. So what order do we come from here? The order is T1 and then T2. Okay, the order identified over here is T1 and then T2, because the final update says that this transaction will occur at the end. No matter what happens, you have to move this transaction at the end. At the end means when comparing T1 and T2, if there would have been any other transaction, it could occur in any like in any order. Like let's say there was T3 also, so we could have T1, T2, T3, T3, T1, T2, like we discussed in the previous example. Okay, so coming back to this question, we have T1, T2. So let's try that if T1 and then T2 is a possible serializable order that we can obtain. Now what we'll do over here, again we'll try to move the operations, all the T1 operations to the front and then all the T2 operations to the back. But the another important thing that we need to take care is read write sequence should not be violated for these conflict pairs. Only these conflict pairs we need to take care of. Okay, so let's start with start with moving the operations. So T1 should come in the front. So this is fine. R1x is fine, right? Let's try to write it over here. R1x is fine. Then which is the other operation? This is the other operation. W1y. Can I move it in front? W1y. Yes, it does not have a problem with this, right? It does not have a problem over here. I can move W1y here. Why it does not have a problem? Both the operations happening on two different items, so it is not a conflict pair. Okay, so I moved R2x here. I just swapped the order of these two. That is not a problem. Okay, now before R2x we also need to move this R1y, right? Because this is the last operation of T1. It has to occur. All the operations of T1 have to happen first, and then T2 operations should come. So can I move it to the front? So the interesting thing over here is that this is linked with this, right? If you see, both are linked with each other. This is a conflict pair. If I move R1 to front, I will swap the order of these two pairs, which is not possible. I cannot change the read-write sequence of a conflict pair. So therefore this is not possible. I cannot move this, I cannot make this swap. Since I cannot make this swap, this T1 is to T2, or T1 happens first and then T2 happens. Serial schedule is not possible. Therefore we come with a conclusion that view serializability is not possible here. The schedule is non-view serializable, or the schedule is non-serializable, right? From the graph, we had explained that if a schedule is non-view serializable, then it is also non-serializable. We have nothing else to check. It is non-view serializable. That means it is not possible to have a serial order corresponding to it. So can you get any view equivalent serial schedules for this? No. The answer is no. You cannot get any view view serial equivalent schedules for this. So that's all for this particular example. That's all for this particular question. I hope you enjoyed this video. You got something informative to learn from this video. Please stay tuned for many such more informative videos. You can post any other of your doubts in the comment section below, and I can get a video posted for that. Also, let me know if you would like me to post any video on any other interesting topic. Stay tuned, subscribe to my channel, press the bell icon, and share to as many people as possible. Thank you.